Hey, STEM seekers, right now we're going to go ahead and go through the answer key to all 5 challenges. It's important you do this because some of the circuits, if not wired correctly, don't work, or sometimes just parts are just kind of funky and they just aren't doing what they're supposed to. So I want you to make sure you do have the correct answers for each of these. Step 1, let's start with answer number, there we go, challenge 1. All right, so challenge 1, what happens when switch 1 is on and closed, or on, and switch 2 is off or open. So the motor spins, the light is super dim. Now, a lot of you didn't see the light being super dim, so make sure you add that into yours. What happens when both switch 1 and 2 are both on? Motor spins faster, light is off. Why? Well, electrons take the path of least resistance, so they would rather go down and around to this switch than go through the light bulb. They go down and around and up and down again. All right, that is the answer for challenge number 1. Number 2, the 3-pitch motor. First answer, what happens when switch 1 is on, closed, switch 2 is switch 3 are open? Speaker makes a sound. How does the sound change when you close switch 2? The pitch becomes louder and higher. And then finally, the reason why, well, switch 2 and switch 3 are closed. The switch has less resistance and more current, more flow, making the sound louder and higher pitch. Number 3, traffic light. Well, with all switches closed on, is there a short circuit? No. Why? The current always is going through the resistor with a load device. So it's going down through here. Okay, even with all these off, okay, it can go through it as a resistor and all the way back around. Now, explain why or why not. The current always has to go through the resistors, which is a load device. And then here's what you should have seen: off, on, off, on to get it on, which you couldn't do yellow. And then green light was on, off. All right. Number 4, this is what you should have done. If you take this potentiometer and you move it to this side, it should go on to the red. And if you move it to the other side with the other ohms, the green should turn on. Toggle this back and forth, and you get each light to turn on separately, which was a bit of a challenge. This is the diagram. Pause the video, take a minute to make sure you draw this properly and label all everything such as red and green. And finally, if you take a light bulb and you put it on a light sensor and then it travels up in through the sound speaker, sound should come through here and then it should go right. This is a simple series circuit right here. And then when you put that light, you can actually change the intensity of the siren based on how much light you add to the sensor. That is the answers for challenge 5. Once again, here's the actual answer you should write down, or you should have something similar. And then, of course, your simple schematic right here. This is the new symbol for speaker, which we just learned about. It says to get the speaker to work, you need to shine light on the photoresistor. This decreases the resistance of the photo. Remember, this is the opposite of a night light. Enough current can now go through the photoresistor and through the speaker to create sound. All right, these are good. When you're done, fill out your paper, turn it in to your teacher. Good job.